Welcome to today's episode. If you are in a kind of a high layer of this software engineering food chain, not the food chain, but in the promotions chain, promotion layers, you may remember in the good old days you learned about something called design patterns, pub sub patterns, and this and that, and so far so on. Today we are not going to talk about those. We are going to talk about design pattern for microservices. But before we begin, I have few news to you. One, if you have any question, comment, concerns, you can send me a mail to krishanta@krishanta.com email address, because I am getting some direct Twitter messages. I am not much active in Twitter. It's okay, you can send me, I will respond, but you can just drop me a mail. I may be able to help you in those cases. Number two, if you feel this video is information worth for you, watching these videos are worth for you, there is a magic button bottom of this video called subscribe button. You go ahead and subscribe that. In that case, YouTube will make sure send you a notification whenever I post new video. So go ahead and subscribe. Okay, that's it. Third news. YouTube last week allocated a dedicated URL for me. Now you can browse this channel, youtube.com/krish. Sound is right. Okay, let's go into this video. So before talk about these design patterns, I just uh, created a small sketch, because I was not sure whenever I am saying these names I may be mispronounced, like not the mispronounced, but swap, okay, A service with a B service with a A. So in that case you may get confused. I have to discuss about few design patterns, but same time I am trying to put this video short as possible. So if I can't cover everything today, what I am going to do is create a new video for other design pattern. But today I am going to talk about main design pattern, which is a aggregator pattern. If you take aggregate pattern, that has three different branches, or other mean three different ways you can implement aggregate pattern. One called service chain pattern, other one called parallel aggregation, other one called branch aggregation. Three different ways you can implement aggregate pattern. Okay, let's take use case like this. Just think you have been asked to implement a microservice platform for let us say IT company, right. So they have a different system, but your responsibility to implement microservices. Remember, we should go with a domain driven design. Just imagine you came up with this type of small design. Service number one, service to get personal information, right, employees personal information. Service number two, to get leave information. Service number three, to get appraisal information, and service number four, to get allocation information, which project employee is working, what are the work allocated to him, like that. Okay, so four different services. Another hand, you have a consumers, like you have attendance management system, and you have a project management system. Okay, for easy of understand, just limit to two. All right. So now we are clear. Okay, so think today they have a system, monolithic system, which has everything inbuilt, right. So they can log into system, they can do project allocation, they can check leave attendance system, they can do everything. This is a whole monolith application. Now your responsibility is to convert this to microservice platform, right. So there are multiple ways you can do, right. So someone may create one microservice for attendance system, other microservice for project management system. If you have some claim system, claim management system, or something like that, you may create other microservices. That is a one pattern. But if you watch my previous videos, you may remember we have to deal with something called domain driven design, and one service should do one, and that should do well, right. Remember, do one, do damn well. Okay. So, now let us go like this. I am going to create a one service to get the personal information, right. I am going to get the second service, I am going to create the second service to get leave information, third service to get appraisal information, and fourth service to get allocation information. You may see now you do not have any service to get personal and leave information for attendance system, right, and there is no service which get personal information and allocation information to your project management system. That is perfectly fine. Okay. Why? Now you have 4 different services, right. So, those are microservices, micro level services. This service alone will not do anything, right, other than what it desired to do. That is fine, right. So, do one thing, do that well. Now, when you go with this kind of a pattern, right. So, now you have 4 different services. You can create 4 different dockers or multiple based on the demand, and you can deploy those. So, now the problem is attendance system need to consume your service, two services. What are those? Personal information service and leave information service. So, now you can create one service, maybe that is a proxy. Okay, let us go with this aggregation pattern. So, you are going to create one service to consume those two microservices and give response back to consumer. That's you can get, you can name the whatever you want, but that what that service will do, it will take the request from the consumer and invoke personal information service and invoke leave information service and aggregate those response and send back to consumer. When you do ESB based development, ESB has something concept called intelligent pipe and dump backend, but microservices is other way around. Okay. So, dump pipe and or dump channel and intelligence backend. So, now when you invoke this attendance service, right. So, what it will do, you can do two things. You can send a parallel calls to personal information service and leave information service and get those responses and aggregate those as a single response and send back to consumer. Okay. So, this is called parallel aggregation, right. So, just think your leave information has a dependency from your personal information. For example, let us say your consumer send employee ID to you, right. So, your leave system still does not know grab information from ID, right. So, maybe the current version of leave system, leave database do not have ID, instead of that they have something called employee code, right, but user will send you employee ID. So, now what you can do is you can invoke personal information service, you can get the employee code from that, you can pass this code into leave information service and get the leave information, and now you can send those aggregated response back to consumer. That is the second pattern, which is service chaining, right. You call one service, get some response, call to other service. There is no reason, no requirement to get the something from the first service, but one after the other. Keep in mind, if let us say personal information service take 10 millisecond response time and leave information system take 10 millisecond response time. So, if you go parallel aggregation, you can get both information theoretically in 10 millisecond. Practically you can't do that, but theoretically you can get those both responses in 10 millisecond. That means you may able to deliver your response within maybe 15 millisecond. But if you go one after the other, that means the service chaining approach. So, what happens is first call will take 10 millisecond, second call will take 10 millisecond, altogether 20 millisecond, right. So, when you put your transformation time into that, more or less it is a 25 millisecond for your response. Okay. So, that is not good, because but there are some scenarios, especially when you migrating from monolithic application to microservices platform. Maybe your backend is still run with some legacy platform, maybe they don't have a relationship, right. So, in that case you may need to implement this service chaining, no other uh, scenario. For example, otherwise let us say you have encoding service, you take some response and you push to encoding service. In that case it must be a service chaining, right, because you have to get the some response and you should send this to encoding or decoding or encryption, whatever the service, right. So, there you can do aggregation pattern, aggregation service, aggregation pattern using service chaining. Other one is a branching. For example, let us say you have a service something like uh, user will send some information, user will send the employee ID and his branch code, right. So, you call the personal information service, and if the branch code is sales, you call for sales information service, and branch information is develop technical branch or something like that, develop branch, then you go and pull his project allocation information. So, that means branching based on some factor, you make a decision, you should go there or you should go there, right. So, that is called branching. So, now we learn three different ways how you can implement aggregator pattern. Okay. So, now what are the advantages when you do this? Just think, today they have, let us say you created 4 microservices and you created other aggregation service to attendance system, right, to attendance system. Then you can create other aggregation service to your project management system. So, what that would do, out of those 4 services, it will call personal information service and it will call allocation information service. Why? It has nothing to do with the leave information, maybe it has nothing to do with the some other appraisal or whatever the information, right. So, now later on they decide, let us say 2 use cases. Use case 1, your project management service decide before they allocate new project, they have to check his or employee leave information, right. So, that means now business logic changed, right. Earlier requirement was, now you deploy it, it is in the production. You have a 2 aggregation service in the production, one is for attendance system, other one is for project management system, right. So, now project management system currently consume 2 services, which is personal information service and allocation information service, right. So, now eventually it is in the production, now eventually their business requirement is changing. Okay. So, they see, okay, when you give allocation to people, they take so much leave, right. So, before you allocate to critical project, you should check how his leave behavior, okay, how much he is obtaining leaves and so far so on. Now, business requirement change. See the beauty of this microservice platform, you do not have to touch any existing services, right. So, what you can do, you can create new aggregation service. Why? Those aggregation service is not take much cost, right. That means it does not need much performance, right. It just aggregation of things, it does not perform any transformation or logic or something like that, right. So, now you you are going to create new service, right, and that service will invoke all 3 services like personal information service, leave information service and allocation information service. So, now you have 2 different services into your project management system, right. So, now what you can do is you can deploy both services into production and you can ask your consumers, hey, now we have this updated service, you can migrate to this one, maybe a different version, right. So, now consumers can slowly, according to their Scrum timeline, according to their plans, right, if they are in agile platform, agile methodology, and based on their timeline, they can migrate into your new service which consume all 3 backends, right. So, meantime, so when you can see all consumers are migrated from existing 2 backend service project management aggregation service, you can shut down that and you can keep this one is live, right. And keep in mind, when you do this type of things, if consumers if your change to your service is not breaking existing consumers, you may don't need to implement new aggregation service. But sometime it would be better you go for new aggregation service, because it's everything is clean, right. So when the last consumer migrated from your existing service to new service, you can shut down previous service. Why I am saying that? Because sometime we have to face a scenarios uh, when we integrate in new services. Because let's say this, your project management system implemented in a way, whatever the you response you are sent to them, and they are serializing into Java objects, right. That may not be a good practice, but that how they do, right. So currently you are sending a response payload along with your personal information and allocation information, right. So what they do is they directly take your response, and if it is a valid JSON, they model into, they serialize into, maybe they use Jackson or JSON or whatever the library, and they serialize into Java object. Whenever you send additional information, their service may be break, right. There are ways you can avoid that, right. You can put some annotation. So in that case, even though they send some additional information, you won't break, but just assume they will break, right. So whenever you deploy your third service which has allocation information, your backend your consumer will break, right. So the only option is the both services, your API, your microservice, and their front end application go onto the production on the same day, same time, right. Those are not meant to do with the microservices, because microservices is there, each team should work independently. I should not depend on you, you should not depend on me. That is the whole idea of microservices, right. So after microservices, if you have a tight coupling, tight dependency each other with each other, it doesn't make any sense. That means you are abusing microservices. So with our pattern, right, we deploy separate aggregation service into production with consume all those three services. Now consumers can adapt to the new response format, and they can migrate their application to production, and we can monitor logs, and when the last consumers also migrated, we can shut down current service, right. So I think this video took much time. So I'm going to finish this video with this design pattern, and going to talk about other design pattern in next video. But one last thing I have to mention to you: when you do this type of service, you need to make sure how your authorization or authentication those flow works, right. Why? I may do other separate video to explain how you should handle authentication on microservices. But for now, but if you validate, let's say you are using OAuth 2, right. So if each service validating your OAuth token, right, if OAuth token validation process take 5 millisecond, so you altogether your 2 services or 3 services take 15 millisecond. Okay, each millisecond on response cycle, it is critical, right. So you should save time as much as possible on your round trip. So whenever you do this token validation on a different service layer, it is take time. So what you can do is you can have separate identity management service, and you can send your traffic whatever hits to your aggregation service through that one, right. So whenever you maybe you should be able to maintain this through web server, right. That's based on your infrastructure, but the requirement is you hit the identity management service and you validate yourself, and that may be intercept your request and add some token or something like that, which each service would verify, right. So keep in mind, whenever you implement authentication mechanism, introduce your authentication mechanisms to your service, there are multiple factors you need to consider. Now, For example, you may need to talk to your infrastructure team, you may need to talk to if you have a security experts, you have to talk to them, right? Because if your service is deploying in a demilitarized area, demilitarized zone, or if your service is behind proxies, reverse proxies or something like that, so the whatever the pattern you're going to use should not vulnerable and should not allow compromise security of your service. Okay. So today we discussed about aggregation pattern on microservices platform, right? So there are multiple other patterns to discuss: proxy pattern, circuit breaker pattern, gatekeepers. There are multiple things. I will do separate video for those because I don't want to have a huge 1 hour, 2 hour, 30 long videos. I believe 30 minutes also too much to watch. Send me your comments, feedback, and make sure you subscribe to the channel, so the next video will YouTube will take responsibility to notify to you, and put this thumbs up button, like button if you like this video, and that's it. Next meet on upcoming videos.